Okay, so let's continue on. Well, before we move on and then incorporate the other classes in here, I want to answer Robert's question before about setting your fields into private and public. Why do you set to private and not public, and then be done with it, right? It's much simpler that way. Sometimes it is, but in the long run, you see that it complicates your code very, very drastically. So, for example, let's just say in the school. Let's see, in school, let's see what student. Let's see which is easier. I think the student class is easier. Okay, so student class we have 4 fields, right? ID, name, address, and the grade. I have an extra S here. Actually, should fix that. Too many S's. I thought it had spell check. Come on. Okay. So if you did it like mine, just fix it. It's a typo. Okay, so back in the main program here. Notice this is a static main. Okay, if it's static, that means that everything contained inside this class here, this function, you can only access static data. Okay, I'll show you what that means. So here you can treat this, even though this is the main program, it has a static main, it doesn't mean that you cannot have a main method over here. You can if you want to. Okay, each of these can have their own main method if you want. The only problem is when you run in this IDE here, if you are inside this faculty file, and if you happen to have a main method here, if you click run, it will run only this file. It will think that this is the main program. It will start here. Okay. Inside this package called ch3.demo. So that's why if these are just like helper classes, then you should have only one main program method. So it will find inside all these classes which one of those has a main function. If the first one it finds exists, it will run that program. And so sometimes you'll get some unexpected result. You can wonder why I have it here, but when I run my program, I keep getting some weird output, right? Because maybe you have different methods, main methods elsewhere. But you can have in other classes too. Usually you don't have it, but it just means you can. Okay, so this is a static main. So far in the last chapter, chapter 3, you probably have created some functions or methods, right? If I have a field up here, just for testing purposes, I'm going to tell you the difference between the static and the non-static fields. So let's just say in the same class main program here, I have a private field called int this number. Okay, I set that to 10, right? I have another private int. Okay, this one I'll call it static. We'll put static in front. Private or private static. I think it doesn't matter the order. Call it int max or something is equal to, I don't know, 25, right? Okay, so one has a static, one doesn't. It looks kind of weird. Let's just put it the other way around. Private, static. Okay. I mean, the order doesn't matter, but it just looks nicer. It looks just kind of weird. That's off. Static void or static anything. Okay, so here inside the static function called main, because the main is static, okay, that means I cannot access non-static fields. So if I want to say something like, for example, int total is equal to number plus 2, right? You see the number is not visible. That's a red underline. You just said it's not legal because remember, number is not static. So one of those rules in the notes is that only static can access static data. Okay, that's just one of the main rules. If it's not static, you can't access it. However, if you change that to max, you see that that's completely fine because max is a static data. Okay, so only static can access static data. So in this case, so how in the world are you going to number in here then? How can you access it? Right? One is you can change it to static if you want. But sometimes you don't want to do that. Okay? If I make it static, this number, a variable called max, can be accessed anywhere from all these classes. Okay? And I'll show you how. Let's see if I save this. Let's just say if I go into the faculty. Okay, remember our program is called main program. Well, one more thing I want to show before we move there. Okay, notice that when I say max, okay, max is a property, same thing with number, it's a property of the program called main, right? Class called main program. Now, usually you would say something like main program dot max, right? No, main is misspelled. Okay, usually you would say that the class name dot the field, the class name dot the function. Okay, so if I have another function down here, for example, so you have a public, we'll call this again static. It has to be static. If it's not static, you cannot access it from that main static there. I'll call it void, maybe like show, and it doesn't do anything. Just put show in there. Okay, so if I want to access that function called show, it's void, so I'm not returning anything, just call it right away. I will just say show, and then that, right? That's a function call, right? And because it's in the same program called, same class called main program, so you don't have to put the main program in front. Main program dot show. Usually that's how you do it, but it's just too much work, too much typing, so you don't have to do that here. However, if you want to call it from in a different class, then you have to call that class, right? So you're going to call from into the faculty. If you want to reach out from this class to the faculty and grab all these fields or data members, I have to call the class name followed by a dot followed by their fields or functions. Okay. So again, so that's why you don't see that here, but that's what's actually happening behind the scene. You don't see it. Okay, so notice I make. Let's make this. Okay, look, this is show is static, right? If it's not static, you'll see that the show goes red. Okay, you can't access it because it's in the static. Okay, so let's create another one here, a very simple one. Public, we'll also make void, we'll just say test for now. Okay, because this is a non-static, and same thing as here, both are non-static. So within the test, I can call the show and has no problem because they're both non-static. Okay, so non-static can call non-static. Static can only call static. And you say, okay, so what if I make this back to static? Right? So you see that if I make this show back to static, both function calls are completely fine. Okay, so it goes to show that. So if you remember, this is very, very simple. Static must call only static data. Otherwise, that's it, but no other way. But the other way around is not true. So a non-static can call both non-static and static data. Okay. So another way in here, I can call the number is equal to 12. Same thing here. Well, this here I can't because this is static. So this one applies to this as well, the same rule. I cannot call number in here. I have to call, I have to make this a non-static. If it's non-static, you can't. So in this example, how do you get this number inside the non-static? remember, any non-static field must be called through an object, right? So in order to use this number, I have to create an object out of the main program. I call it prog is equal to new main program. Okay, only an object can access the non-static fields and functions. Okay? So that's the only way. There's no other way. If you want to use it here without creating an object, then you better make this as static. Otherwise, if it's static, then if it's static and if it's public, I'll show that later. You can cause some very some side effects. So now I can say prog dot, and then here you have the number int and the max. No, max is not here because max is static. So you have the number is equal to, if I change that to number, to let's just say, I don't know, 12 or something. I can reset the number to 12. So now, because any fields that are instance or are non-static belongs to the object, and the way I do here is like this one here. So in other words, if you have the non-static, they are private to an object, whereas this one is static, is available to all other objects. I'm not sure that makes sense. Okay, I'll do an example to show you here. So we have a main program called prog1. I'll call this prog, and I'll have another one here. Okay, we won't deal with the number and the max here. So we have another one here, main program prog. I'll call 2 and new main program. Okay, I'll change this to 1 so I just make it easier. Prog1 and prog2. So I have two objects created of this main program, and they're completely independent. Okay, so now they both have copies of all these functions plus the main method plus the number and plus the max, right? Everything you see here belongs to both of them, and they have their own copies. So I can say prog2.number is 34. Okay. So if you print this out, if we go SOUT control spacebar, right? Remember that one? I print the prog1. I just put the output for the prog1's number. So prog1.number. Okay. You can copy this and duplicate it 2 times. We print prog2 as well. So SOUT control space prog2, the prog2's number. So if you run this, you should see 12 for prog1, 34 for prog2. Okay, so run it now. And okay, I should save that. I didn't save that. Yes, I'll post it up. Yeah. So here we have prog1, 12, prog2, 34, right? Very simple. Just to show that they share the same property number, but each of them they have their own values, right? And that's what make it an independent entity, object of the same class. And there's no way for prog2 to change prog1's number, and vice versa. So if it's an instance field, then they are encapsulated. Okay, they hid it inside the object. You cannot change, you cannot see it. However, this is static. Okay, static data is available for all objects. Okay, all objects can see it, they can access it, and they can change it. If it changes, then every other object also can see it, and it can also affect their data if they want to do some type of calculation. So here, if I say, right in here, if I put prog1 dot max, if I change that to 45, okay, initially was 25, I changed prog1's max to 45. So in here, I'm going to duplicate this, both of these, this line here. I also want to print the max out for prog1's, which is prog1 max, and then just put prog1 dot max. And they do the same thing down here for prog2. So prog2 max, prog2 max. Okay, you notice that I did not change anything for prog2 dot max. And you would assume that since I didn't change it, prog2 dot max should be 25. And if you save and you run it, you see that that's not true. Okay, they both have 45. Alright? Because the max is static. The static is visible to all other objects. And if you change one, you change everywhere else. And if you do some calculation, you'll be incorrect because you might do something like what? You might say, oh, you know, oops. You might do something like, I want to do something like this. I'll say like prog1 dot number equals 12 plus prog1 dot max, and I expect that to be oh, that's hard, right? I can't calculate. Yeah. And then if you do the same thing for prog2, you would think that prog2's number and times equals, 2 times prog2 dot max. You might expect to get the same result, but if you want, you may not, because now prog2, the max has been changed to 45 instead of 25, and then your result will be really different because that max is accessible to other objects, and if they change it, it affects your calculation. Okay? So if that's the case, then you make that static. Otherwise, make it non-static, and so it's encapsulated, right? And this is an example of like your bank account. You have your total account in your bank, and you give your spouse or your family members each of their check card, and we all access the same number. And if you pull cash out, you see that your account actually decreases. You can see it, right? And this is an example of a static data. Or if you think about game, if you all multiply a game, and where you like inside this, Diablo 2 or something, and we shoot this devil at the end of the scene, it has a lifeline of the boss. We all shoot that boss, and you see his lifeline going down. It's a static data. I can see it, you can see it. It affects everybody. Okay, so that's what a static data is. Is that clear? Okay. So static data uses sparingly because you can have really unexpected results in your calculation. Okay, so again, so this is a static. So static, remember that you don't have to create program object to access it. I can just access it directly. So here, in other words, I didn't have to do prog1. I could just say max is that. Okay, and it would still be changed. So if I put, like, for example, 560, okay, put max here. Even though I say prog1.max, prog2.max, you see that both will still be affected. Okay, because it's really, there's no point of using a non-static to access a static data. It doesn't matter because it's the same thing. Again, it's available to everybody. Okay. So what that means is that I can access this data from the max from the faculty too. So if I go here, if I say, for example, if I just say private, you don't have to do this, int x is equal to, I want to get the number from the main program, I can just get main program dot max, but I have to make max public. Okay, so make that public so it's available to the other class. So you can see that I can access it directly, but the number I can't because it's an instance. So to get that again, what do? You have to go main program p is equal to new main program, right? And then now I can say p dot number. Okay, so you cannot access non-static data directly. Again, you have to make that public. Okay. Right. Doesn't like it. Well. So that's how you access like this the print statement. Like here, I could do system.out. I don't have to say system is equal to new system and so on, right? Because these are all static. Okay, so the other question was, now I'm really going to answer your question. Why do we set public and private? Okay, so remember that in here, if I go into, let me turn these off, all these off. Okay, go on the top here. All right. Now, if I want to create a student object out of student class, right? I'll just say student S1 is equal to new student. Okay? And if I want to access the student data, I will have to say S1 dot, you can see they have the getters and setters, get and set, because there's no data, all this will be just empty string. I'm going to change the student ID, so it's set ID, and I'll pass a number of 1, 2, 3. Okay? And you can do the same thing for the other set ID, set name, and so on. But just say we'll just do that one. Because it's private, I have to use this function. Right? So what if you make it public? If I make student ID public, okay, let's save that. You see that this should still work because it's just a function call. I could do that, or I could just say s1.id, right? See, it's visible. All those three are visible because all those are public. I could say sid is equal to 345. I just changed the ID to 345 now. Okay. So you can change that. You can output it to that way. You can just say, SOUT. I put student ID, and then just concatenate that with the s1.id, right? Because you treat that just a variable name. It can be both setter and getter. Or I can do it again, and I'll just say student ID again, 2. I'll use the get ID. I'll call the function get ID. And both will be the same. So both will display 345 because I set it and then I set it again to 345. And when you run this, you'll see that it has 345, right? Just as expected. And so you may wonder, why would I waste my time creating this setter and getter? And the issue comes when you have this. Imagine I have this ID, or even this, being called elsewhere, like down here, you know, no, not here, but like other places, a lot of places. Okay, and in this case it works fine because there's no error. As you can see, no red marks. If I run it, everything will be like 45 a lot here. Let's just say that, you know what, and I decided I want to change this to private. And now you're doomed, right? Because now it's no longer accessible. All the IDs, you can't access those, but these are still okay because they're still private. So that's one case. Okay. Now I have to go and change all of these in my code to call the get ID. That's one case. Another case, if it's still public, and what if I say, you know, I want to change this to student ID called SID instead of just ID, right? So I changed that here in my code here. I changed that here. I changed one here. I changed three places. I'm done here. But over here, again, that same problem. I have all these lines. I have to go and change it to SID. Okay, not in just this class. I could call this in maybe multiple classes, and I call the S one of that ID.
So you do that so that you only have to, you can get the variable or set the variable only one time and then call it.
Mm-hmm. Right. So now, if I were to call get ID or set ID, notice this, there's no effect, right? Because this function never changed. I didn't change it. This will stay the same, get ID and set ID. All the changes is this in here. I can change this to whatever I want, the field to something else. I just have to do it 3 times, and the other place can occur in the main places. It doesn't matter. Okay, so you can see the advantage in that. That's the second rule. The third one is if you have back to the ID. If you do it this way, then something like this. There is no way of validating your code. Okay, I could put some number here. ID, just example, is integers. I may not be a big deal, but if it's a string, for example, or it could be a string that could hold a script to a database, right? So that string that holds the query can actually be a SQL injection code that you can run to make a query in your database. Can actually delete your data. So there's no way of validating that because when I run this, it's going to go and then load into this string here or ID, and then I process down here, then it could generate error or cause some problem. But if you force it to go through the get ID or the set ID, then I have more control of the code. Before I set the ID, I can validate to make sure that this ID coming in is a valid data. Right? So I didn't put it here. We can say if ID is something something, then go ahead and set it. Otherwise, say it's invalid. Okay, so you have total control of the input. Okay, so those are just some of the major issues, or I should say advantages of using the setter getter to get your IDs. All right, any questions? Okay, so now let me go ahead and clear all these out. So we got the static, while we set the encapsulation to private. The next one I want to cover is overloading. Overloading is where you have a function that has the same name, but you have different signature. Okay, so we do the overloading for the constructor first, and then we do the function. So if you go back to the student, you gotta go to the student class. Okay, here we didn't have any constructor yet, so by default, if you don't supply one, Java will create one for you. Java will create a very simple empty constructor for you. That's why I was able to generate a student class or the main class. We didn't have the constructor for the main program, but we're able to use that in here, right? We would say main program proc1 and proc2. Okay, there is a constructor in here, we just didn't see it. Okay, Java creates one if you don't provide one. So in the student class, I'm going to create a constructor, and the default constructor will be just public, and then followed by the name of the class. This name is the student, and this is an empty constructor. So this is a default constructor. So Java will use this same constructor to create your object. It just create an object for you, and then that's it. Okay, so this is an empty one. So that means when I create a new student in the main program, I will just do student s1 like I did there is equal to new student. And that's the only option I have. I cannot put any parameters in here. If I put, ID 1, 2, 3, it will fail because there's no such constructor or function to receive that data, right? So if I create that one there, so that's what you see. I have to call the set ID to set the ID, set the name, set the address, set the grade, and so on after that. Okay, so you do the setting manually. You can also have a different constructor, the same name, right? But notice that if I do an empty one, you have a conflict. So it doesn't know which one to call. So you have to have a different signature. So this one here must have a different signature, meaning the parameters must be different. So I could say I want to provide just the ID for this one. Okay. So when I receive the ID, I can set this ID equal to this ID. So this ID here will be set to this ID here. So the rest of the, you can still set them if you want to. Let's just say we only set the ID. So notice this is the same as this down here, right? So you could do that, or you can say, you can do like set ID, and then pass the ID to it. So you pass this ID to it, to that set ID function down here. And why would you do that? It's like, well, why do that versus what I just did, right? If I do that versus this ID is equal to this ID. So what's the advantage of this two? They do exactly the same thing. Why would I do that? Back to the other example I showed you. What if I change this to SID, right? Again, back to the same problem. I change that, and then I have to change this too, and then elsewhere, right? So if I use the function call, then I don't have to worry about inside the constructor. I only have to change here in two places. I'm done. Okay? So I prefer to use the function call function to set the ID. And not only that, it's even better if you have another function call, maybe something like this, void init. And then you initialize the data. You pass all those data to it. That's, again, that's another way. So you can just call the set init inside the constructor and initialize your code. Okay, so there are lots of ways to do it. You can do it any way you want. Okay, but I'm just showing you the different constructors here for now. So we have one with the student ID. I can have another one, student with this one. I'm going to just have the name, for example. So if you say string name, and then I'll just set name and pass the name to it. So you provide all these possibilities so that when you create a new object of the student class, sometimes I want an object has no initialization. Sometimes I just want to create one with just the ID. I just want one with the name, right? Instantly. And then you can create one with maybe the name and ID. Student say int ID and then string name. And these are all legal because they have different signature. Empty have an int type, the string type has int and string. Not only that, you have 2 parameters versus 1. Okay. And you have so you have all these combinations like 1, 2, 3, 4. So you can have how many types in here. You can have a lot if you want, if that's the case. And you can have one. Maybe I just do one more. This one we will have all of them. Public student have the int ID, the string for the name, string for the address, string for grade, and then we'll. So again, here I will just set the ID, pass ID to it. Set name, pass name to it, right? And then you do the same thing down here. Set ID, ID, set name, name, set address, address, and then set grade, grade. And if you look in the book in my notes, there's actually another, there's a shortcut for this as well. Okay, there's something wrong in here. You have that triple S's down here or something? I did. Ah, still gets me, right? Okay. I think that's it, right? Yeah. Okay, so you have, I have like 4 constructors here. Okay. Oh, what do I do? I do something to it. Up here. So I have the blank, just the ID, name, and then have 4 of them. So I have all those available. So if you go back to the main program, and now if I want to create a second student as student 2, S2, equal new student, if I type in the command, you see all those options coming up. You press the inside here, you press the control space bar. You see I have the empty constructor with the ID with the name, ID and the name, and one with all of them, right? That's how they are showing up here. We got the different constructors. Same thing when I do this. I could say sysout, and then press control space bar. You see here, you have print here, print boolean, print char something, print double, print float, right? Same thing. These are different methods. So those are called constructor overload. Here again, I could put just 1, 2, 3 for the ID. It will match. It will find this argument type. It's an integer, and it will match that type inside the student class, and it will use this one because this one has only 1 parameter. Even though this one here has the int as ID, it needs a second one too. Since I didn't supply one, the compiler knows that it's going to call this one, okay? Because it has to match that signature. Okay, so you provide all these availability. So here we have what's called the constructor overload. So overload is you can have the same constructor or function in the same class. Okay, it has to be in the same class only. I can't have like, I mean, it doesn't work if I put this in the school class. It's got to be a completely separate class function inside the school. But in the same class, if I use the same constructor or same function name, but had different signatures, this is what's called a constructor overload or method overload. A method overload is the same thing. I can go down here, like the init here, right? Initialize, I could pass in int. I could pass none. Same thing. It has, say public void init. I'll pass just the integer of ID, and then inside here, it looks very similar to the constructor. Just set ID, pass ID. Okay, and then I'll do one more here just to show public void init int ID, and then string name, and then I'll set ID, and then set name, passing the name. Okay, so these are method overload. Okay, overloading the methods means I'm changing the signature of each of these functions so that when I call them, I have more options. Just this is the same thing as saying inside the SOUT here. I'm doing print nothing, print with the boolean, print character, same thing. Right? So if I go back to the main program, if I say student 1 dot, you see I have init, init void, init ID, and name, and so on. Okay, so I can choose one of these and then just supply the arguments, and I can use that. Okay. So that's overload, and we'll do the override next week. Override is a little confusing, but we'll repeat that again in chapter 10 when we do in the inheritance. So the last 5 minutes or so, I'm going to just quickly go over the assignment. So just in case if you want to tackle it ahead, that's good. Okay, and there's a lot more to cover, so I'll just stop here for this demo here.